Welcome back to Aurora Tech Channel. Today, I am going to review the latest Elegoo Neptune 3 Pro and Plus printers. These two machines are pretty much identical. The print volume of the Pro is 225 by 225 by 280, and the retail price is $230. The Plus has a larger print volume of 320 by 320 by 400 and is priced at $350. There's also a Max version, which has a print volume of 420 by 420 by 500 and is priced at $470. This pricing seems pretty aggressive, so let's take a look at the hardware of these printers. First, they all use a direct drive extruder. In terms of the extruder design, it's pretty similar to the Ender 3S1 series and uses a Bondtech clone dual gear extruder. They have a dual Z-axis with a timing belt and use an inductive auto bed leveling sensor. The print surface is a textured PEI spring steel sheet. They come with a 4.3-inch capacitive touchscreen as well as all of the mid-range printer upgrades, such as LED lights, belt tensioners, filament sensors, 32-bit boards with STM chips, silent stepper drivers on all axes, and clean cable management. With all this hardware for a super low price, the price value is actually amazing. In addition to testing out the normal printing speed, I will also experiment with increased print speeds. I will compare the performance and print quality of the Klipper firmware with the stock Marlin firmware by connecting the machines to Creality Sonic pad. I'm very excited to explore these features and share my results in this video. I would like to thank Elegoo for sending me these machines to review, and to Creality for supplying the Sonic pad to me in this video. And with that, let's get started. We have the base, touchscreen, gantry, filament holder, some tools, and a power cable. The structure of this machine is really simple, so all you need to do is connect the gantry to the base and tighten the 4 screws underneath, mount the screen on the right side of the frame, mount the filament holder on top, and connect some cables. Flip the power supply to your local voltage, and finally, check that the eccentric nuts of the X and Y axis are tight enough to make sure they don't wobble, and check the belt tension too. Everything looks good, so we can turn on the machine. The screen UI is pretty clean and is similar to that of an Ender 3 V2. Since this machine uses an MKS motherboard and screen, Elegoo reprogrammed the screen UI to make it more usable. As there are no leveling knobs under the bed, it will just let the auto bed leveling sensor do its job. The sensor does 36 points on this tiny bed, which I think is a little bit overkill. Then we will set the Z offset and heat up the machine to feed in some filament. I will start by printing a calibration cube with Eryone Rainbow Silk Candy PLA. While the cube is printing, I will put the Neptune Plus printer together. It is essentially just a pumped up version with 2 support rods for the taller frame, and instead of having no leveling knobs, it has 6 knobs under the bed. I will let the Neptune 3 Plus print the same G-code file and see how both prints turn out. They both look pretty much identical. On the Y surface, I found that the Plus has more ringing, which may be caused by the larger bed, creating more momentum to swing back and forth. Besides that, they both look okay, and the dimensions are also accurate. Next, I will slice another 3D benchy and let both printers run the same G-code again. The smaller Pro took 1 hour and 36 minutes to finish, and the Plus took less than a minute longer. So the speed is still pretty much the same. The print quality is really nice for both of them with no cooling issues. The Plus does have a few tiny stringing, but other than that, I can't see any differences. Then, I will print a model of the Elizabeth Tower, also known as the Big Ben, on both machines. It took them both 15 hours to finish. As the maximum Z height of the Pro is 280mm and the maximum height for the Plus is 400mm, I printed both of them at 280mm for a better comparison. It's interesting that the Plus is still stringing a tiny bit, but it's not that big of a deal. The tip of the tower looks good on both of the printers. Next, I will print some TPU using the Pro. I'm going to print a large flexible lizard model. It took a little over 9 hours to finish, but this lizard was printed beautifully. While the lizard was printing on the Pro, I printed ABS on the Plus. I will use the same Conger smoke filter as an air purifier while printing ABS. I will print a small screw box, and I'll start by printing the lid directly on the PEI sheet to see if the ABS can stick to it. As expected, without an enclosure, and because it's printing in my cold garage, the corners warp, especially the bottom left corner. Still, the other corners don't look that bad, so I'll just apply my favorite Elmer's Craft Bond extra strength glue and try to print the body of the box. This time, it sticks perfectly and the print looks good and is still usable with the lid. Next, I will try printing with nylon filament. As this roll of nylon has been open for over a year, I will dry it first using this new filament dryer from FIXDRY, which can heat up to 70 degrees Celsius. I will dry it for 6 hours. After that, I will keep the spool of nylon inside the box and keep the heating on while printing. The nylon is printing very well. This may be the best nylon print I have made with this spool of Overtune Nylon over the past year. It looks as good as PLA with 0 issues and overall is a perfect part. After that, I changed the nozzle on the larger Plus printer to print a large trash can that almost uses up the entire print bed. The extrusion looks good. I printed this at 25mm per second as the filament needs to be melted pretty quickly with the large diameter nozzle. Since this is the standard hot end, I just want to make sure it doesn't cause under extrusion. The model was finished with perfect extrusion, but as you can see, there is a crack here as this is only a 1-layer thick wall and the entire body is hollow. It seems a 0.8mm nozzle with the same line width is not strong enough to hold the model. The trash can is unusable as it can easily break. Then, I used the same nozzle with the same speed and settings and printed a scaled down version. This time the extrusion was also perfect and the trash can is usable. The bottom and the inside all look good without any issues. Using a large diameter nozzle to print something this big only took less than 4 hours. Next, I will try something more extreme. I will switch to a 1.2mm nozzle to print the full-size trash can and see if it works. I will print at 10mm per second to make sure the filament can melt fast enough. At first, it prints alright, but as you can see, later on the extruder gear is turning really fast to keep up with the 1.2mm diameter nozzle. After a while, the extruder stepper motor overheated and stopped moving. I stopped the print, and after a few minutes, I started to extrude some filament and it worked again. So I guess I may have pushed it too far using the 1.2mm nozzle. Then, I switched back to the 0.8mm nozzle and printed the scaled down trash can with PETG to see how it looks. It also extruded perfectly and had zero issues with PETG using a 0.8mm nozzle. Okay, I have pretty much tried all the materials on the stock setup. So next, I will install Klipper on both printers and use the Creality Sonic pad to control them. I've prepared the config file for Klipper and the motherboard firmware, which I will put under the video description. You just need to copy the bin file to the root of the SD card to flash the printer and copy the printer.cfg to the USB drive that came with the Sonic pad. Insert the SD card to flash the printer firmware to Klipper. You will see the boot screen for 15 seconds, and then when it shows update firmware, it will just stay like that forever as Klipper only supports classic LCD screens. With the Sonic pad, I will use the 7-inch tablet to control the printer, so you can simply unplug the screen if you want. My Sonic pad was factory reset, so I will set everything up from scratch. Select the language, agree to whatever it says, select the time zone, and connect to your 2.4G Wi-Fi network. For non-Creality printers, scroll all the way to the end of the list and select Other Models. Depending on which port you plug your printer into on the Sonic pad, you may need the serial port ID. My config file assumes you plugged it into port 1, so if you use another port, just change the MCU section to your port number. Insert the USB drive that contains our printer.cfg, and it will load the config and set up the printer automatically. If your config file is incorrect, it will keep repeating and it will require you to log in using the terminal or the web interface to configure manually. However, if your printer hardware is the same as mine, you should be good. But I can't guarantee that, as printer hardware may change from time to time. So if you do decide to use my config files, good luck and use them at your own risk. After a while, when you see the success message, it will perform a self-test. It will test the heatsink fan, part cooling fan, and show the leveling menu, starting with setting the Z offset and followed by auto leveling. Now, you can use the Sonic pad to control the printer. A small bug I found is that no matter how I try to rename the printer, the Sonic pad still shows unknown printer, but I don't have this issue with Creality printers. I'm not sure if it's just my own problem, but let's keep moving. I will then set up the plus using the same process. The only difference is that I connected it to port 3. I then used the accelerometer that came with the Sonic pad to calibrate input shaper on both machines. I don't want to design another mount, so I just used duct tape to tape it onto the print head. After the x-axis is done, I taped the accelerometer on the center of the print bed and did the y-axis. Okay, the Klipper setup is now done. Let's open our web interface. As you can see, I have two printers. The default one is the Pro. You can use the IP address directly or use it with port number 7125. For the Plus, since I installed it on port 3, the port number will be 7127. I will now set up the Moonraker plugin in Cura. Just send the print job directly to the IP address with the port number or without the port number if you only have one printer connected. If you want the preview thumbnail, you can choose UFP, which is the Ultimaker format. Or, if you don't care about the thumbnail, you can just choose regular G-code. I will start with the 120mm per second profile that I previously made for the Ender 5 S1 using the Sonic pad. The speed is 120, but only when printing infill. It will print at 60 for the walls and 40 for the first layer. The acceleration is set to 3000, but for a small print like this, anything between 2000 to 3000 won't make a huge difference. I will just send the print and start it directly from Cura. Okay, the Sonic pad is responding, and the web interface is also showing the same print job. It ended up taking 54 minutes and 38 seconds, which is around 50% faster than the stock setup. The result looks pretty good, and the cooling is also okay. I will compare the benchies printed at different speeds with the stock standard speed at the end. I then tried to print at 150 and 200mm per second. As you can see, the surface still looks clean even when printing at 200, but we start having some cooling issues if the speed is 150 or faster. As the surface still looks pretty good, I want to add an external fan and keep pushing the printer using the Sonic pad to print at even higher speeds. We're going to use this 12V 1.6 amp 120mm fan and mount it on the side of the printer. To show you how strong this fan is, let's turn it on and set it to its maximum power. It can actually blow the benchy away, so cooling definitely won't be an issue anymore. Let's retry 200mm per second. As expected, there are no more cooling issues. I then tried another one at 250 with a 0.25mm layer height. The print took just 34 minutes and 7 seconds to complete, and the result is still presentable. Let's compare the stock setup at 60, the Sonic pad at 120, the Sonic pad with extra cooling at 200, and the fastest 34-minute benchy with the Sonic pad, extra cooling, and a 0.25mm layer height. I am quite happy with the results. Let's talk about the pros and cons of these two printers, starting with the pros. 1. These printers are built with high-quality materials, surpassing those found in budget machines. When printing at a standard speed of 50 to 60mm per second, the print quality is excellent. Even when the speed is increased to 120 or 250mm per second with 3000mm per second squared acceleration, the print quality stays presentable. 2. The Neptune Plus has a total of 6 leveling knobs, which is more than the standard 4 knobs found on other printers. This feature may work better with a larger bed, especially on budget machines where the heat bed may not be completely flat. As for the standard size Neptune Pro, due to a smaller print bed, it no longer requires leveling springs. The bed leveling sensor is designed to do its job, and it works quite effectively like it does on a Prusa MK3S Plus. 3. Using an inductive limit switch for bed leveling is a low-cost alternative. It may not work as fast as the BL Touch or CR Touch, but it is definitely more stable than the 3D Touch or the strain gauge leveling sensor, and I didn't have any leveling issues throughout my tests. 4. The PEI sheet is of high quality, and it sticks pretty well to all commonly used materials like PLA, PETG, and TPU. For ABS and nylon, I can print without issues if I have glue applied. 5. The capacitive touchscreen is highly responsive and is of high quality. The UI structure is simple, clean, and fully functional. It also uses an MKS Robin Nano motherboard. While I'm not a big fan of the Robin Nano screen UI, Elegoo has reprogrammed the screen UI and has done an excellent job. Common issues when using auto bed leveling and setting the Z offset that I found with other MKS motherboards no longer exist on these Neptune Pro and Plus printers. 6. Both printers work well with Klipper. I connected both machines to the Creality Sonic pad, and they can produce presentable results at a speed of 120 mm per second using the stock hardware. When I added an extra large fan to the Neptune 3 Pro, it was able to print even faster at 200 or even 250 mm per second. 7. At this price range, you get the full package, including almost every feature you could possibly want, such as a dual-gear direct drive, auto bed leveling, a dual part cooling fan, a color touchscreen, a dual Z-axis with a timing belt, a solid base, belt tensioners on both the X and Y axis, a filament sensor, and clean ribbon cable management. I can't see any machines in the same price range that can beat these two. Now for the cons. 1. The hot end assembly is a bit bulky and extends quite a bit at the front. As a result, I have to tighten the eccentric nuts tighter than normal to prevent it from wobbling. This may lead to another issue, as the rubber wheels seem to wear out faster than they do on other machines. 2. The stepper motor is not very strong. When I tried to use a 1.2mm nozzle on the Neptune Plus to print at a 1mm layer height, even when printing at just 10mm per second, the stepper motor stops responding before the first layer finishes, which may be because I pushed it too hard. But when I switch back to a 0.8mm nozzle and print at a 0.64mm layer height, it works perfectly fine. 3. Using a USB drive or a full-size SD card instead of a micro SD card would be preferable. It wouldn't cost much to change to an SD card slot. Personally, I don't like micro SD cards on non-camera or mobile devices that don't really need to limit the physical dimensions of the storage media. 4. The slicer profile in the latest Cura 5.3 is not tuned well enough, but just using the Ender 3S1 profile works fine. In conclusion, at a price point of $230, there's nothing else in the market that can beat the value of the Elegoo Neptune 3 Pro. It offers the full package, including features typically found in mid-range printers that cost $300 to $400, and the build quality is still pretty good. Therefore, I would call this the king of budget printers. If you're a beginner looking for a printer, don't bother with those under $200. Just get the Neptune 3 Pro for $230. In addition, the Neptune Plus, which offers a print volume of 320 by 320 by 400 and the same full package, is an incredible bargain at $350. There are also no other mid to large size printers available at this price point that can match the value offered by the Neptune Plus. Initially, I had planned to test out the Neptune Max, which offers an enormous print volume of 420 by 420 by 500 and costs only $470, which is a pretty crazy price. Unfortunately, the Max is currently sold out. But since it shares the same extruder and most components with the Pro and Plus, I assume it should also work similarly. In my opinion, the new Elegoo Neptune series outperforms all other budget 3D printers currently available in the market. While it would be even better if they came with all metal hot ends that support 300 degrees Celsius high temperature printing, the current offer is still an excellent deal. If you are interested in these machines, I included the links in the description. That's all I wanted to share about these two machines. If you found this video useful, please consider liking and subscribing to our channel. Thank you for watching, and I will see you next time.